Assalamu alaikum everyone, welcome to today's video, which is we will be starting from where we left off in the last lecture video, and hence we will start with syntax and semantics. So let us get started. Syntax and semantics are mostly theoretical features, and understanding them is actually quite crucial and essential for developing working codes. Okay, though they are completely theoretical terms in nature, they are actually the very building blocks that make a code do what it does. It works. So if we go line to line, semantics is the meaning of an instruction. That is, when we say the semantics, it's actually meaning that what does it want to say. So an instruction is an order that the program needs to execute. So this is an explanation of what I said about instruction. So an instruction is an order that program needs to execute. A program, okay, is a sequential or procedural execution of instruction. Gentle reminder, we are learning about procedural programming languages in this course. So a program is a sequential or procedural execution of instruction. As you can see, step by step we are expressing different terms. Now each instruction needs to be syntactically correct. Okay, now what is the difference? I already have brought the two words that I have given over here as headers. What is the semantics, and here we have the syntax. Okay, so syntax errors can be identified by compiler. Semantic errors are beyond the control of compiler. Okay, so what is the syntax? Let's give an example of using a normal sense. If I say I am okay, then I give a question mark at the end of the sentence, is actually wrong, because the written sentence over here is not a question sentence. If I said am I okay, that would have been a different case. If if I had written am I okay, then yeah, it would be a question mark at the end. But suppose in that case, if we give a full stop, these are syntactically incorrect sentences. Okay, so this is a syntactically incorrect sentences, and if these stuffs happen, then see, it's a syntax errors, and our compiler a compiler can actually identify them. When compilers identify, as we saw in code blocks, it can be seen that it shows errors and identifies which lines are of errors. For example, and if you miss semicolon at the end of a statement, it can identify that yes, you have did a mistake. In simpler terms, syntax errors refer to very easy rules, grammatical rules. If they are violated directly, it can easily be understood. So this type of errors can be understood using the compiler, and it can say that you are doing the wrong thing. These are the syntax errors. Next comes semantic errors. Now here comes the problem. Semantic errors cannot be identified by the compiler. Why not? Because let's say about the example, cow eats grass and cow eats meat. I've given here two examples. By far we can say that cow eats grass is the correct sentence, but cows cannot eat meat. Cows do not eat meat. But if I say about the grammatical rules, there is nothing incorrect about this sentence. It's completely correct. It's only illogical that cows will eat a meat. So this type of this sentence is also incorrect in that sense, and this type of mistakes is called semantics. And there is no specific amount of rules that we can use to differentiate this from the correct one. So hence this type of errors are semantic errors. Semantic errors hence need to be addressed by the coder. The one who codes, the one who programs, he needs to or she needs to identify and correct, because the compiler cannot ever point out that you are doing a semantic mistake. No, it can't. It never ever can do. If you do a syntactical error, it will identify that you are doing a syntactical error. Modern compilers even provide a warning and make corrections to the syntax errors you provided, but semantic errors they are way beyond the ability of the compiler to identify, and this type of errors are the main errors that you need to be careful about. For now, though, you will mostly do mistakes in the syntax errors portion, but as you practice, it will get more easier for you to check syntax errors. But semantic errors, they always live with you, they always stay, and you always need to be careful not to do them at all. So these are very important facts while writing code, is syntax and semantics. And this is not only for C, this is actually for all programming languages. You must be careful. The syntax errors, they are always identified by the compiler or the interpreter. The semantics, they cannot ever be identified, and you must remain careful. Once again, this is true for all programming languages, not one or two, not only C, but all programming languages follow this convention. Okay, now syntax and semantics, when we are talking about it, we need to talk about another thing. Over here I am calling this the identifiers. Now identifiers actually cover a wide variety of stuffs, such as one is the variables, another is the constant, and we have function and such topics, but like structure, name, and other stuffs like that. But so far we have only studied variables. Okay, so I will explain identifiers based on variables, but the rules that I will be discussing go similarly for constants, functions, and just as mentioned, and they are all together called identifiers. So while saying identifiers, I will be mainly discussing some rules regarding variables. So let's see, what are the identifiers, but please do not forget this term identifiers. We will be needing it later on. Just so you easily understand, we are considering variables for now. What does identifiers do? Identifiers represent a name in C program. Okay, represents what? A name. This is an important part. It gives a name, it provides an identity to you, and that's why it's an identifier. It provides you a name in the C program. Actually, C program would be narrowing it down. Identifiers are used every language, mostly every programming language has its own set of ability to create identifiers, and most cases they all follow the same conventional rules. So we should not limit it to C program only, because we are discussing C. I have written C, but it is actually true for all programming languages. Okay, but the identifier name must follow certain constraints. Over here I have written some of those constraints. An identifier can have letters, both uppercase and lowercase letters, digits, and underscores. Okay, the first letter of an identifier should be either a letter or an underscore. Should be a letter or an underscore. That means the first letter of identifiers cannot be a digit, though it's an acceptable part of the identifier, but it cannot start with a digit. You cannot use keywords as identifiers. What the keyword is explained in the next slide. Identifiers are case sensitive. What does this mean? It means that the variable var and the variable var, though spelled as exactly same, these two variables are different because, as written, case sensitive. It can detect lowercase letters and uppercase letters. So these two are completely two different identifiers. They are not the same. They are different identifiers. But yeah, we do not promote this kind of use of identifiers. We like to use different identifiers in different cases, not just use this property of the identifier at all. Okay, and hence there comes the another part. There is no rule on how long an identifier can be. You can write a very big name, it's not a very big deal. However, you may run into problems in some compilers, some old version compilers. I don't know if the recent ones do so. Identifier cannot be longer than 31 characters. So I don't know if some compilers still follow this convention. It was a convention that was used before. And this type of rules, mainly these are the rules that you should follow while trying to declare or work with identifiers. Well, we will see some examples during this video in the next part. Now before we dive into that, let's start with keywords. Okay, there are some reserved words in programming language. Those are reserved words. Why are they reserved words? because this represent a certain action. For example, if I provide you and say that according to rules, is int a valid identifier name? According to rules, yes, it is a valid identifier name because it contains letters. It has length of 3, okay, and it has nothing except the letters. The first one is not a digit. Every rule it satisfies, but it cannot be used as an identifier because it is conflicting in one of the rules, that is integer is a keyword. By writing integer we declare a data type, so integer cannot be used as an identifier. But then again, as I mentioned, because it is case sensitive, capital NT can be used as an identifier, though once again, as I said, it is not promoted to use such cases. But int as a keyword, it actually has an action associated with it, and hence the reserved words in programming language or the keywords cannot be used as identifiers. They satisfy the rules of identifiers, but they cannot be used as one, as mentioned earlier. And keywords have fixed tasks, and using them as identifier results in errors. And over here I have also given the integer example as well. So these are the words of the keywords and how identifiers works it out. Okay, now comes another part where we say the syntax in C programming. We try to delve ourselves a little bit more into it because, as I mentioned earlier, syntax can be accessed or understood much easier than the semantics. So syntax in C programming, so program execution starts from the main function. If you remember, we writing, or if you have experienced some code, you always remember that we always write a main function, main, and after that there is a bracket. Before that something remains, which I am calling here the return type. Okay, the return type, it will be present over here, and then we have a body of code. Later on we will learn more about function, so here I have given the function name. In our case it is the main, and there is a set statement sequence. Okay, so main is always needed in a C program, and no matter how large or how small your code is, the code execution starts from the main function, and everything must remain inside the enclosed bracket of main. After main we give a set of curly braces and write our code inside those curly braces. Everything must remain inside these curly braces. Well, not everything, but we will discuss about those later, about function calls and global variables that actually remain outside of the main. But for now, just so you know, everything must remain inside the curly braces of the main. For now, we will discuss later about topics where there should be something outside the main as well. But for now, just don't forget, whenever you do whatever you do, the main function needs to enclose everything. Okay, so after it's done, after the code starts from main, it goes from line to line. Whatever is written in the first line will be executed, then in the second line, then in the third line. It does not skip, like I did the first line, then I will do the third line, then I will do the second line. No, it never happens. It will always follow first, second, third sequentially. So these are the syntax of programming language. Oh yeah, and in C, every statement in C ends with a semicolon. Not every language follow this convention, but in C every line must end with a semicolon, and it is most common syntax error that you have missed a semicolon. In every statement must end with a semicolon. Please remember this, please memorize it, you will be needing this a lot. Okay, another important syntax is variable declaration. And if I want to declare a variable, I will first need to write the data type over here, then I can write the variable name. It is more like I am now, by this line I have declared that in this code I will be using something called a, something named a, and it is of integer data type. Just as the name suggests, this name or this line or this statement of the code is actually declaration, variable declaration. We have declared a variable that will be used in the code, and This can be of different data types. You can obviously change the name as well, but it's very important that before you go on working with a variable, you must always declare the variable itself first, then you can work with the variable. Without declaration, I will try to show an example. The compiler gives the error that no, you have not declared the variable you're trying to work with. Okay, now comes basic IO functions in C. Well, before the main, we actually write a line include stdio.h. If you remember, stdio stands for standard input output. Okay, and in the code you write something like printf, scanf, and such, right? So what does the printf and scanf do? The printf prints something on the console and scanf takes some input from the user. Okay, and how does the printf and scanf function work? It's actually written in this file. If you look at your PC, if you search your PC, you will find this file, and this file actually contains the definition or the working procedure of functions like printf, scanf, and many more functions like this. So the working procedure of printf and scanf will mainly be covered in lab course, because there you will learn practically how to print something or to take input of something. We will not dive much deeper into this topic over here right now. So before we start discussing or continue on to our next topic, I think we can start by a little understanding of the codes of what we have learned so far. So let's get started. Okay, so first up is, as I mentioned before, we need an integer main. Okay, this is written integer main void return 0. What happens if I say you need to be built? There is actually no error. You see, I have not written the header file. But if I write printf printf hello and try to give it a build, now see, it's giving me warning. It has already detected, and it is suggesting me over here that you should include the stdio.h that contains the declaration, provide a declaration of printf. Either I can write the declaration of printf, that is write the function itself, or I can include the stdio.h header file. So that's what I'm going to do right now. I'm going to declare the header file, and that's why we always suggest you provide this much as at least when starting to code. Take it as your skeleton code, start with at least this. Okay, so now if I give it a build once again, sorry, I actually mistakenly removed printf. Now if I give a build, now it's all okay, because it's printf is defined in stdio.h. okay, that's all for now. Okay, now let's say that I want a comparison to be done between two numbers. I'm going to say integer a is 5 and integer b is 6, and I want to see if a is equal to b. So I can write printf the comparison result. If you remember what I said, okay, let's declare a variable c, integer c equals to, I want to say see if a double equals to b is true or not, that is if a is equal to b. Okay, so let's see what happens. %d comma c. Okay, let's see. Now my code says no, a is not equal to b. Why? Obviously a is not equal to b. A is equal to 5 and b equals to 6. Now when it comes to semantics errors, for example, I have mistakenly removed from double assignment to a single assignment. Now this has become an assignment operator, and now if I run the code, the answer becomes 6. Why? Because the value of b is 6 and the value of b is given to a, which is also becoming 6. So the whole thing returns a 6, and that is returned to c. Now you see my target was the comparison result. The comparison result is should be either 0 or 1, but now the comparison result has become 6. Why? This is a semantic error. A compiler cannot ever detect semantic errors. Once again, I'm warning you, be careful about these semantic errors. If you miss this semicolon over here, it will guide you. It will say that you are missing a semicolon. I'm expecting a semicolon over here. It will even mark it that before this line there should be a semicolon. If you miss it over here, even it will say that no, I'm missing a semicolon over here, but there is no correction for the semantic error which you have done. There is no correction for it. There is no compiler who can detect it. So you need to be careful about semantical errors like this. Okay, now next comes, for example, let's just say that I remove the declaration of C. Okay, I just write integer C equals to A double equals to B. Now if I give a build function C, it gives C is undeclared. Until you declare a variable, you cannot use it. So this is a syntactical error, that you first need to declare the variable name. Now I'm going to declare integer C. Now see, it's all okay, the code is working. So you first need to declare. This is a syntax of C programming language or many programming languages. I can say all programming languages require a variable declaration, some actually do not, but C requires you to declare the variable before you start working with it. So this is the declaration part, and now comes the variable parts. Suppose you want to declare a variable called integer 4. Okay, now you want to say for equals to, if you look carefully, these variables are of different color, and this one suddenly turned into blue because for is a keyword in C programming language. Okay, so if I write for and I provide a build, it gives an error. It says that there should be a bracket after for, because when I have written a for, it is expecting me to write the syntax of a for loop, which is like this. So that's why for starts with a bracket, and hence is giving me that you should provide a bracket also. Okay, so what happens if I provide a syntax of something that is not of the bracket? So let's say I say the name is in character cha. Still there will be errors, right? Still there will be errors. The two or more data types in declaration specifiers. It just means that this is syntax errors. Okay, because when you write something, it tries to follow that convention. Sometimes in this type of syntax errors can lead up to semantic errors depending on how you write the code, but this is mostly a syntactical error that you must remain careful about. You cannot use keywords as names. Okay, now for the remaining rules of naming. Okay, one thing we said that variable names can contain small letters, capital letters, and digits and underscore. Let's just declare C over here so that the error is gone. Okay, you see that this is all okay, but as the condition specifies, a digit cannot be as the first member of the variable, though an underscore can be. So these are the conventions of naming identifiers, and these are all semantic errors. And semantic errors, syntax errors, and as I mentioned earlier, syntax errors are always capable of being identified by the compiler, but be careful with the semantic errors. Syntax errors do tend to be disappeared from your coding. Just if you practice coding, you manage to understand syntax errors very easily and you start avoiding them as well. But semantic errors, that also requires practice, a lot of practice, so that you do not get into trouble with it. So yeah, that's pretty much it. So let's get back to our presentation. So this is not much of a left. So different programming languages, let me just go through a little difference of different programming languages. So there are many different programming languages, and many differences are seen usually in syntax, but they essentially share most of the common ideas. They use for I have seen, of all the programming language I've seen, I don't recall even a single language that does not have the for loop, or that does not use the int as a keyword. So they essentially share most of the common ideas, but the difference mainly is usually in syntax. One says you must provide a semicolon at the end, one say nah, the semicolon is not required. One say you must specify the data type before declaration. Some say you can just say it's a variable, we will detect it automatically. This type of syntactical difference are present between different languages. Hence, learning one language thoroughly helps to learn others much faster. If you learn one language very thoroughly, the other language will be learned in much smaller succession. If you say your first programming language takes you 7 or to 8 months to learn completely, you can anticipate that you can learn the next programming language in 2 months or so. And the more you get the grip of it, the lesser time it actually takes for you to learn. So concentrate on learning one language very well, then you can easily learn other languages very fast. So that is it all for this lecture. Thank you very much for staying tuned. Inshallah we will meet again in the next video. Assalamu alaikum.